Welcome, my dear learners, to another exciting episode on Stable Tutorials. In today's lesson, we shall be looking at Pythagoras Theorem, also known as the Pythagorean Theorem. Remember, we are still on Plane Geometry 1. But before we start our lesson, let's look at our lesson objective for the day. So by the end of today's lesson, you, my students, should be able to state and use the relationship between the hypotenuse and the other two sides of a right-angled triangle. This is what you are supposed to know and do at the end of this lesson period. Kindly like, share, and subscribe to this very channel for more updates. So, we are looking at the Pythagorean theorem, also known as the Pythagoras Theorem. Now, we have two words being combined, Pythagoras and then theorem. What is a theorem? A theorem is a statement that has already been proven to be true. That is theorem. What about Pythagoras? Now, Pythagoras is a name of a great mathematician who lived around 570 BC. He was a Greek and a philosopher as well. So Pythagoras and his school came out with a theorem, and this theorem is what we are going to look at today. Now, this theorem describes the importance of geometric relationship between the three sides of a right-angled triangle. A right-angled triangle. So the theorem applies to only a right-angled triangle. And I believe that at this very point, each and every one of us knows what a right-angled triangle is. If you've forgotten, let me remind you small. So this is our right angle triangle because of this very symbol. It is a triangle with one of the angles being equal to 90 degrees, and this side is equal to this 90 degrees. So this is what we are going to use on Pythagoras theorem. Now let's look at the theorem. What does the theorem say? Now the theorem says that in every right angle triangle, the square of the hypotenuse is equal to the sum of squares of the other two sides. That is what the theorem is saying. The key word here is a right-angled triangle. Now let's look at the right-angled triangle and then let's see if we can identify the hypotenuse and the other side of the triangle it is talking about in the theorem. So this is our right-angled triangle. Now, in a right-angled triangle, the longest side is called the hypotenuse, as described in the theorem. So the longest side here is called the hypotenuse. Hypotenuse. And then the other side are called the other two sides or the other legs of the right-angled triangle. So we can say that the other sides are called the other two sides of the right-angled triangle. Now the theorem is saying that the square of the hypotenuse. So let's call this side A. So the square of the hypotenuse is equal to the sum of squares of the other two sides. So let's call this side to B and then C. So we have A squared, the square of the hypotenuse, which we have denoted it with A, is equal to the sum of squares of the other two sides. This is what the theorem is saying. So the arithmetic expression for the theorem is A squared is equal to B squared plus C squared. Good. Now you know that a squared is the same as a multiplying a, and then b squared, we have b multiplying b plus c multiplying c. This is the same as this. Now, let's look at the geometric aspect for this very theorem. This is the arithmetic aspect. Let's look at the geometric interpretation for this very theorem. So we are going to draw a right angle triangle of side 3, 4, 5. That is the Pythagorean triple set of numbers. So we are going to use set of numbers or a triangle, a right angle triangle with side 3, 4, 5. So let's draw the right angle triangle with this given size. So this is our right angle triangle. We already know, or we know that the longest part of the triangle is the biggest number among the set of numbers. So we have 5 here, and then the other two smaller sides, we can give it to the other two sides. So we can write here to be 4, and then here to be 3. The most important thing, you should be able to identify the longest part. Good. Now what we are going to do next is, we are going to draw a square on this side of the triangle, and then a square on this side of the triangle, and then a square on this side of the triangle. And the square is going to be a side of the length given. So we are going to draw a square of 4 sides. We are going to draw a square of 3 sides, and then a square of what? 5 sides. So let's do so. So what we are going to do next is, we are going to divide each of the squares according to the size given. So we are going to divide this side into 4, both this side and this side. We are going to divide this side into 3 parts, and then this side into 5 equal squares. So 4 equal squares, 3 equal squares, and then 5 equal squares. So let's do so. Good. So this is what we are having now. Now the next thing we are going to do is, we are going to count the number of squares on this very side, and then we add it to the number of squares on this very side to see if it is going to be equal to the number of squares on this very side, which is the hypotenuse. So let's count the number of squares on this very side. So we have 1, so we have 16 squares. So we have 9 squares here. Let's count the bigger ones. So we have here to be 25. Now, the theorem says that the sum of squares, so we are going to sum these squares and these squares to see if we are going to get 25. So we are going to get 16 plus 9. So what is 16 plus 9? And I believe you are saying 25. So the sum of these two squares is equal to the squares on the hypotenuse. So this is what the theorem is telling us geometrically. So anytime we are being given a right angled triangle, and then we have to find the unknown side of the right angled triangle, we can use the geometric interpretation or the geometric method or the arithmetic method. So we have our example on the board, and then we are going to apply the Pythagoras theorem to find the unknown length of the right angle triangle. So the first question says that we have to find the length of sides of the angles. So the first example, we have to find the length of sides marked with letters. So we are going to find the length of this side. Okay, and this side we know it is what? The hypotenuse. Good. So looking at this very triangle, first thing you have to check whether it is a right angled triangle. So per this symbol, we can say that it is a right angle triangle. So if it is a right angle triangle, then we can apply the Pythagorean theorem to find the length of this unknown side. Good. So the Pythagorean theorem says that the square of the hypotenuse, or this, is equal to the sum of squares of the other two sides. So you are going to get s squared is equal to 15 squared plus 20 squared. Good. That is what we are going to find. Now, so we have s squared is equal to 15 squared will give us 225, right? So we have 225 plus 20 squared will give us, I think, 400. So we have 400. So we are going to have s squared is equal to 225 plus 400. We are getting 625. Now we have s squared and then 625. We are looking for the value of x, not s squared. So what we do, we take the square root on both sides of the equation. So we take the square root on both sides of the equation. Now this square will cancel this root sign or the radical sign. So we are left with x. Now the root of 625 is what? 20 plus or minus 25. Now, so we can say that our x is equal to negative 25 or x is equal to 25. But since we don't have negative length or negative side, we are not going to take this. So we are saying that our x is equal to 25 meters, the unit attached. Very, very simple. You see how simple it is? Good. Apply the Pythagorean theorem to find the value of BC. So let's say this side is XBC. So that I write the next question on the board and then we try our hands on it. So solve it. So I hope you were able to find the value of x. Let's solve it together to see if you are on the right path. So you can see that this is a right angle triangle, and from Pythagorean theorem, we are saying that this is the longest part and it's called the hypotenuse. So the square on the hypotenuse, which is this, is equal to the square of the other two sides. So we have 13 squared will give us 169, and then 5 squared will give us 25. We have our x squared. Now we are looking for x, so we are going to transpose 25 to this side. So we are going to get 169 minus 25 is equal to what? X squared. So 169 minus 25 will give us 144 is equal to x squared. So what do? We take the root sign on both sides so that this and that will go. You can say our x is equal to root of 144 is 12. So we can say that our x is 12 centimeters. I hope you had 12 centimeters. Good. Now we have another example on the board. We have to find the value of x. So we have 3 triangles in one question. So we are going to find the value of x. Good. Now To be able to find the value of x here, or the length of x here, we need to find the length of AD, so that we can apply the Pythagoras theorem to find the length of what? X. So let's find the length of what? AD by applying the Pythagoras theorem, because we have a right angled triangle. So we are going to get 17 squared is equal to a squared plus what? AD squared. Now 17 squared will give us 289, and then 8 squared will give us 64, and then we have plus AD squared. Now what we are going to do is we are going to transpose the 64 to the other side of the equation. So we are going to get 289 minus 64 is equal to AD squared. Now 289 minus 64, we are going to get 255 is equal to AD squared. So we take the square root on both sides of the equation so that this and that will go. We have our AD is equal to 255. Root of 255 will give us what? 15. So we have 15 meters. So our length, which is AD, is equal to what? 15 meters. Now that we know the length of AD, we can use the Pythagoras theorem to find the length of what? DC. And I hope you can do that by squaring 25 and then equating it to the square of 15 and then the square of what? X. Very, very simple. Good. So what we are looking next is the Pythagoras triples. The Pythagoras triples. Now triple means what? 3. The Pythagoras triples consists of 3 sets of positive integers that obeys the Pythagorean theorem. So when you have 3 numbers and then these 3 numbers obey the Pythagoras theorem, then we can see that these 3 numbers are called the Pythagoras triples. So an example is this is a Pythagoras triples because it obeys the Pythagorean theorem. Now the Pythagoras theorem says that the square on the hypotenuse is equal to the sum of squares on the other 2 sides. So looking at this, now the longest side is always the highest number. For that one, it's clear. The longest side is always the highest number. And then the 2 smaller numbers are the other 2 sides. So looking at this, the longest side is the 5. And then the other 2 sides are the 2 smaller numbers. So if we are to write this with respect to the Pythagoras theorem, we are going to get 5 squared is equal to 3 squared plus 4 squared. Or if we are to draw the triangle, the right angle triangle, we are going to get the 5 to be on the hypotenuse and then the 3 and 4 on the other 2 sides. So applying the Pythagoras theorem on this, we are going to get what? This. And we know that 5 squared is 25. And this will give us 9. And then 4 squared, we have what? 16. So we have 25 is equal to what? 25. So this set of numbers obeys the Pythagorean theorem. So this set of numbers are called Pythagoras triples. Let's take another example. Let's take 6, 2, and then 8. So let's look at 6, 2, and then 8. 6, 2, and then 8. Let's verify to see if this set of numbers are Pythagorean triples. So we know that the longest side is the biggest number. So if we are to draw the triangle, the right angle triangle, we are going to get this. The longest side, which is 8, and then the other 2 sides are this. You can the other 2 sides, you can interchange them. it will never change anything. So applying the Pythagorean theorem, we are going to get 8 squared is equal to 6 squared plus 2 squared. So we have 8 squared will give us 64. 6 squared will give us 36 plus what? 4. So we have 64 and this will give us 40. So you know that 64 is not equal to 40. So this set of numbers are not Pythagorean triples. Very good. Now verify to see if this set of numbers are Pythagorean triples. So we have 7, 6, and then 4. Verify. Good. So what did you get? Are they Pythagorean triples? So let's try. So we have 7 squared is equal to 6 squared plus 4 squared. So 7 squared will give us 49, 6 squared will give us 36, 4 squared will give us 16. So we have 49. So this and that will give us 252. And we know that 49 is not equal to 52. So this set of numbers do not obey the Pythagoras theorem. So they are not Pythagoras triples. Is that clear? Good. So these are a list of questions that are prepared for you. Kindly pause the video, write them down, and then you try your hands on it. But make sure you like, share, and subscribe to this very channel for more updates. See you next week. Bye bye.